Good morning. It is Groundhog Day, as well as February 7th, 2022. We kind of had that break. So we started on Groundhog Day, had a 4-day weekend where we kind of got our own Groundhog Day on Monday the 7th. So here's our do now. What's the order of the 3 seasons? What is Wegner's theory of continental drift? And what was one piece of evidence to support the theory of continental drift? So you're going to go into Schoology. I'm going to show you how that is. And you're going to come in here. Now, it's a little tougher. The do now is labeled 2-2-3. That's because we didn't get to change it, but we're going to go with that. And the daily slides that I'm going to go through today are right here without narration. Now, again, as always, you will find your recording at this point right here below. And this will be the start where we started to talk about continental drift and walked through the slides. So let's go back to the slides so you know, and these are posted every day. So you have these here so you can listen to us walk through the slides, do the slides, and do any work you have so you don't have to come back owing us work, so you don't have to tell anyone, say, hey, I missed this. You're good. All right, so now that you've had some time and you're due now, what are the order of the seasons? Absolutely. Yep, spring, summer, fall, winter. Remember, that also relates back to when we did the rotation and revolution unit, when we did the sun, the earth, and the moon, so that we could do that. And we had the ability to locate those as the earth travels around, it does its revolution around the sun. So kind of a flashback to make sure we're getting our brains working and connecting all the dots. What was Wegner's theory of continental drift? Oh, so that all the plates, he believed that at one point all of the land masses were one giant landmass. Well, how did he support that? What's one evidence? I see lots of hands. Okay, so we could use fossils that were found in South Africa and South America. They're hugely, vastly separated by the ocean, so those are kind of cool. Or plants found in both places, so it's kind of cool. All right, so let's look at our teaks today. I will analyze evidence for the theory of plate tectonics. I will identify and model plate boundaries and the crustal features that they create. And then I can identify the theory of plate tectonics and analyze evidence that supports the theory and describe, model, and label the boundaries: transform, divergent, and convergent. So here on slide 7 of your digital notebook, I'll make it a little larger, are some puzzle pieces. And you want to put those together. You want to move them around as best you can. They may not fit, but we're going to also add in here, it says, then search the map for 2 plates that exist in 2 places. Remember, this is a flat map of a round object. So I'm looking around. Oh, there's the Eurasian plate. So I'm going to draw a little arrow here and click that there. Ooh, let's move that a little bit so you can see that. There you go. So you can see the arrowhead. Oh, I wanted an arrow. So I click on arrow. Take this and I'll just draw that in. See, we all do that. Oh. So there's my arrowhead, because there's also a copy of the Eurasian plate. So I'm going to click on the arrow again, click and point, and where I drop that last piece is actually where the arrowhead will be. Here is Wegner's theory of continental drift in plate tectonics. So this is going to help you put together slide 7. If you're stuck, ask you, how do you think the plates could have moved? We're going to watch the video, and you're going to type a summary on slide 10 of your digital notebook. So you're going to want to watch this in the daily slides. The link will not work in this recording. So here we talked about, after that, was words that started with these prefixes: consent, content, conduct, converse. Okay, I think we're going to add one more. How about construct? There we go. So all of these, and means together or bring together, die, to, or split. And the prefix sub means under or below. All of these would. So these are some really cool ways to think about it. All right, so that's slide 10. So let's do this. Let's take a look at slide 10 in our digital notebook. Oh, I'm going to go in there and go get my digital notebook. Because yes, I have my own copy. So we're going to go down here to slide 10. And that's where you should put those in there. And you have directions here on the side. All right, so let's go back to today. So then here's another video, kind of help you out with convergent, divergent, and subduction zones. And then we're going to ask you to move this around. So as we're looking at this, all right, so convergent, where they come together. Right, I got some great examples. I'm a little stuck on that one. It says where the two plate boundaries move towards each other. All right, I like that. Okay. And, oh, there they go. They come together and they actually build something. They make something. If these don't fit, you just want to slide these over just a little bit. Okay. Subduction. Well, they talked about the ocean plate in the video and the, where the denser plate sinks. So we're going to put that there. So, oh, and yeah, the ocean trenches, the mountains and the volcano rings, because right here there's an ocean trench and a volcano. So we have divergent, pulling apart, and our little friend transform here. And if you want to just shrink them to fit, you just kind of push them together. So we're going to fault lines and earthquakes. Yep, because that's what they talked about. Oops, make that too huge. Let's grab that. Bring that over. Strike slip. There we go. And we're just going to put the blanks in where they go because this is a plate boundary where they move away. So we're going to get rift zones and ocean ridges. That was a huge one in some of those videos. Now, yeah, we can have ocean trenches here, but we're also going to have volcanoes and some mountains. So this is going to be good. All right. So we took a little break to ask you if you could build your house. What's one room it would have? All right. So if you're not with us, so you're not going to be able to do this. You completed this pretty well, so I'm pretty good. And here are some examples. Some pictures of some trenches and some explanations, a deep sea floor spreading. Here's a rift zone where they begin to separate. This is a cool video. You could see that. We have our ridges and the divergent. Each one of these layers is when the magma cools and it forms a layer, then it splits. So the older material's on top of the younger because somewhere here it'll split again. So that's really cool to kind of take a look at that. Here are some underwater mountain ranges, long volcanic activity. That's a divergent plate boundary. We have convergent, where we talk about the making mountains. Mount Everest, they're saying, is growing about 2 inches a year or 10 centimeters. We talk about the ring of fire, convergent, because these are all coming together. All right, and here's a bigger close-up of that. And if you notice this is one large plate, and the ring of fire talks about all of these volcanoes, these really big hot spots here. We have our faults, and this is actually the coast of California. We actually see 3 of them, where it's divergent, convergent, and transform. Okay, the transform is where we have the earthquakes here when they're slipping and sliding. Right here is the divergent, where you can see the actual split. And then right here we have, up at the top, we have the Earth's crust meeting the ocean plate for our convergent boundary. And then our exit ticket poll is this. This is a released STAR question, so the best part is that if you ever want to see what was on the STAR at your grade level, all you have to do is Google STAR, STAAR, released tests, 8th grade, and they will show you all the old ones. You want to look at ones that are 2019, 2020, or 2018, but nothing later than that. A teacher asks a student to make a model of a transform plate boundary. The student uses the blocks to represent tectonic plates and slides them past each other in the direction of the arrows, so up and down or left and right. Which event could be best described? An earthquake, a volcano, a rift valley, or a building of a mountain? We can go back and look, but I think, yep, you got it, friends, an earthquake. All right, we will see you all on Tuesday the 8th. Have a great day.